Here are some more sums based on acceleration. A racing car has an uniform acceleration of 4 meter per second square. So acceleration 4 meter per second square. What will be its velocity after 10 seconds here from start? So it is starting from rest. So your u initial 0 meter per second. We see the time is 10 seconds. We need to find its final velocity. V is what we need to find. So we use the formula A equal to V minus U over T. So we have 4 equal to V, we don't know, 0 over T, 10. So 4 into 10 equal to V, 40 equal to V. So final velocity is 40 meter per second. So its final velocity after 10 seconds will be 40 meter per second. A body starts to slide over a horizontal surface with an initial velocity of 0 meter per second. Initial velocity is u, 0.5 meter per second. Due to friction, its velocity decreases at a rate of 0.05. So the acceleration here is 0.05 meter per second. But there's a very important thing. There is a decrease. And because there is a decrease, we are going to put a negative sign here. There's retardation taking place. How much time? So time we need to find it will take to stop. Stop means V final equal to 0 meter per second. So formula acceleration is V minus U over T. Here the acceleration is minus because it is retardation. We see the V is 0, initial velocity 0.5, time we do not know, so we put T here, we cross multiply, the T goes here, we have 0.5 over minus 0.05. We cancel out the negative signs and we got 0.5 over 0.05. Now we need to get rid of the decimals. So to get rid of the decimal in the numerator, we will put 10 in the denominator, and in the denominator we have 2 decimal places. So here we will put 100. So here we get T equal to 5 into 100 over 5 into 10. You cancel this out, the answer is 10 seconds. So it will take 10 seconds for the body to stop. It will take 10 seconds for body to stop. A train starting from rest. So initial velocity 0 meter per second. Moves with an uniform acceleration. So here is the value of the acceleration, 0.2 meter per second square for 5 minutes. So time is 5 minutes. Now minutes is not SI unit. We've got to convert the minutes into seconds. So 5 into 60. So the time we will take is 300 seconds. Find the speed acquired. So we have to find the final speed. Here again use the formula of acceleration, A equal to V final minus initial over time. So acceleration is given as 0.2, so 0.2 equal to V we need to find, so we write V as it is, minus U is 0, so initial 0, time is given as 300. So 0.2 cross multiply, we take the 300 on the other side, so into 300 equal to V. And when we multiply this, we get 60 equal to V. So V equal to 60 meter per second. That will be the speed acquired. speed acquired equal to 60 meter per second after 5 minutes. A bus moving with a speed of 54 km per hour, so that will be initial speed 54 km per hour. Now this is not SI unit, we got to change it to meter per second. So we have to multiply 5 by 18 to make it meter per second. And after you multiply, you will get the answer. You cancel, you reduce, you get 15 meter per second. On applying brakes, it stops. If it stops, means its final velocity is 0 meter per second, because it stops or comes to rest in 8 seconds. So time equal to 8 seconds. So we need to find its acceleration. So acceleration equal to final minus initial over time. So acceleration we don't know. 0 minus u we saw is 15, and time we see is 8. So the acceleration is minus 15 by 8 meter per second square. The next question is, why did we get a negative sign? The negative sign indicates that the body has slowed down. Body slows down. So in this case the bus stops. So there is a retardation. There is a slowdown of speed. There is a retardation, hence the negative sign. A motorcycle moving with a speed of 5 meter per second, that's initial velocity 5 meter per second, subjected to an acceleration of 0.2. So acceleration 0.2 meter per second square. Calculate the speed of the motorcycle after 10 seconds. So final velocity we need to calculate after a time of 10 seconds. So we use our acceleration formula, A equal to V minus U over T. See, the acceleration is 0.2. So 0.2 equal to V, we do not know. U is 5 and the time is 10. So 0.2 into 10 equal to V minus 5. So here 2 equal to V minus 5. V equal to 2 plus 5, because the minus 5 goes on the other side, that is 7 equal to V. So speed after 10 seconds equal to 7 meter per second. A brakes applied to a car produces an acceleration of 6 meter per second square in the opposite direction. This is important. That means acceleration is 6 meter per second, but opposite direction, hence acceleration is negative. If the car takes 2 seconds to stop, so time is 2 seconds, calculate, here's a mistake, it's going to be final, calculate the initial, because we already know the final velocity is 0. The body stops here, so final velocity V must be 0. The reason is body stops. You apply the brakes and the body stops. We here have to find out the initial velocity. So the initial velocity U is a question mark. We've got to find that. So we know acceleration V minus U over T. We put the values. Acceleration, remember, is minus 6 because the brakes are applied as retardation. Final velocity 0, U we do not know, and the time is 2. So minus 6 into 2 equal to minus U. Minus 12 equal to minus U. So 12 equal to U. And U is initial velocity. Initial velocity equal to 12 meter per second. A train starting from rest u equal to 0 meter per second, attains a velocity of 72 kilometer per hour. So final velocity is 72, but it is kilometer per hour. We cannot work in kilometer per hour. We've got to make meter per second. So 72 we do 5 by 18 to make it meter per second. And on cancelling, here we get 20 meter per second. So remember, our V is 20 meter per second. And in 5 minutes, so time 5 minutes. And the minutes, we also can't work in minutes, so we do 5 into 60 to convert into seconds, which is 300 seconds. Now for acceleration, A equal to V minus U over T. The final velocity 20, initial was 0, starting from rest, time is 300, so acceleration is 20 over 300, and you cancel the zeros out, and you cancel 2 and 30, and you get acceleration 1 by 15 meter per second square. A car accelerates uniformly from 18 kilometer per hour to 6 kilometer per hour. So this is initial, final. So initial 18 kilometer per hour, 18 meter per second, 5 by 18. So when you're making kilometer per hour, this would be now 18 cancel, 5 meter per second, initial velocity. Now the final velocity denoted as V is 36 kilometer per hour. So it is 36 into 5 by 18. And on reducing, here we will get 10 meter per second. And the time given is 5 seconds. Here they have mentioned 5 seconds. So time 5 seconds. Now for our acceleration, we have A equal to V minus U over T. So acceleration V we see is 10, U is 5, and time is 5. So A equal to 5 over 5. So acceleration is 1 meter per second square.